Okay, welcome to video 3. Transformations. Give the information to answer, or use the given information to answer the following. So algebraically, so f of x is 6 minus 4x squared. G of x is f of x plus 5. Find g of x. So we got to get rid of that f of x part here. So let's replace that. F of x is, well, that's equal to this. There's nothing fancy inside here, so I don't have to do anything with that. So we could just take this and make it 6 minus 4x squared plus 5. And there's nothing keeping these parentheses in, so we can drop the parentheses and then collect like terms. So I have a negative 4x squared, and then, so don't need the parentheses. And then I have a positive 6 plus 5 is going to be plus 11. So that is g of x. Negative 4x squared plus 11. If you kept 11 in front, if you did 11 minus 4x squared, that's fine because they did that up here. But usually you put the highest power first. Okay. Give the table of values for f. So we got to find g of 5. So g of x is equal to this, so everywhere there is an x, we will place in a 5. So that is going to be 3f of 5 plus 2. So we need to take care of this f of 5 first. So when x is 5, f is negative 2. So this whole thing should be negative 2. So that's going to be 3 times negative 2 plus 2. Put that there. F of 5 equals negative 2. 3 times negative 2 is negative 6 plus 2 is negative 4. So g of 5 is negative 4. And then domain and range. Given the graph of f has a domain of this and a range of this, let g of x equal negative f of x plus 3 minus 2. Find the domain and range. So that means that we have taken f and we have vertically reflected it. So that's my vertical reflection right there. So that's essentially you're going to multiply all the y values by negative 1. And then I have another vertical transformation right here. This is going to be a vertical translation. So we're going to take all of our y values and we're going to subtract 2 from it. And then I have a horizontal measurement here, a horizontal transformation. So that is going to be a horizontal translation, and everything works backwards here. So we're going to take all of our x values and we're going to subtract 3 from them. So the green, this green right here, that is going to be what we do to y values. So that's going to be our range. That will affect the range. And our blue here will affect the domain because those are horizontal values. So this domain actually looks easy. There's only one step. So we need to take all of our domain values and subtract 3 from them. So the original domain was negative 5 to 3. So negative 5 minus 3 becomes a, so the domain of g is equal to negative 5 minus 3 is a negative 8. And then 3 minus 3 is a 0. And we'll use the same open parentheses that they used. And then our range. So our range is like this. So we need to multiply it by negative 1 first, and then we need to subtract 2. So negative 4 times negative 1 is positive 4. Positive 4 minus 2 is 2. And then there is 8 times negative 1 is a negative 8. Negative 8 minus 2 is a negative 10. So, and then before we move on, since this is a vertical reflection, multiplying by a negative causes everything to flip. So we need to make sure we write this properly. it needs to be negative 10 to 2. The smaller number must go first. So there is our domain and range. Okay, calculator active. Regression. Oh, regression is a next week thing for you guys, so it's not going to be on this test. So we can move on. This next one, calculator active. Here we go. A diver jumps from a cliff to the water below. The function h of t is equal to, well, this right here. This is going to model his height of the diver, where t is the time in seconds and height is in feet. What is the restricted domain in this context? So what we can do here is that we can switch over, since it says we can use a calculator. Let's throw up a calculator here. And we could type in our function. So this is going to be h of t is equal to, we got negative 16 t squared plus 14t plus 80 plus 14t plus 80. And then we will zoom out a little bit. Let's get this kind of into perspective here. Okay. And so there is our function. Now, it's asking us, what is the domain restriction? So when I talk about domain restriction, we talk about two things. One is the mathematical restriction, like what doesn't make sense mathematically, what breaks the graph. And the other one is contextual. So mathematically looking at it, if you look at just the math aspect, there is no there's no breaks in the graph. This is a quadratic. It's continuous all the way. There's nothing weird mathematically that restricts this domain at all. So that tells us that there is all real numbers. So there's no restriction here. X can be all real numbers. It's not a big deal. No mathematical restrictions at all. So there are none. Now, in context, what doesn't make sense in context? In context, well, let's see here. It models the height, jumps from a cliff. So it starts measuring when he jumps from the cliff. So it doesn't make sense to have negative time. So we want all of our non-negative numbers. So 0 and greater. That's going to be important. And then it doesn't make sense in height in feet. So since we're measuring from the height in feet, that means 0 is the ground. So if we look at our graph, wrong button. It doesn't make sense for him to go beyond the ground down here. Like there's this big, unless he's phases through the earth, but I don't think that's going to happen. So it should be right around there. So because he's going to hit the ground, it's going to be from 0. It's going to be from 0 is the starting point all the way until the diver hits, well, hopefully the water, I guess, not so much the ground. If he is diving, well, he jumps off a cliff to the water. Yeah, he's hitting the water, hopefully. Unless something's gone horribly wrong. So we'll just round to 3 decimal places, 716, 2.716, and that's probably going to be in, what, seconds? Yeah. And these are in seconds, so we'll put seconds out here. So if I combine these two, all real numbers, but really only these, that's the only one. Since there's no restriction on the mathematical side, the domain should be 0 to 2.716 seconds. And then once he hits the water, it's going to be slightly different. The the range. So the range is going to be all the possible x values. If we wanted to, let's say if you want to figure out, if you don't want to get confused by the extra stuff on the graph, what you can do is, now that you've figured out the restricted domain, you can type it in. You would type in 0 is less than or equal to t, which is less than or equal to that number we put in, 2.716. And there's going to be a little rounding error where that doesn't touch the, well, it kind of does. It's fine. There we go. So now we really only need to care about this part of the graph. And so my lowest low is 0, and my highest high is 83.063 feet. So the range ends up being 0 is at his lowest point at the very end of the dive, and at the very peak of the dive, he or she is, what did I say it was, 83.063. So always round to 3 decimal places, and that'll be in feet. But always round to 3 decimal places. Okay, that concludes video number 3, and I'll see you guys on the next page.